Every Christmas Eve, the same impossible story repeats itself. A single man, a single sleigh, a team of reindeer, and somehow, in one single night, presents are delivered to every child on Earth. Not a country, not a continent, an entire planet. Millions of homes, millions of kilometres. It's a story most of us grow up with, rarely questioning how it could possibly work. So tonight, let's put aside belief, tradition and magic for just a moment. Because this isn't a story about whether Santa exists. It's a story about what the laws of physics would need to look like if he did. Welcome to a festive episode of the Real Science of Sci-Fi. Before we start talking about warp drives, wormholes or quantum sleighs, we need to understand the sheer scale of Santa's task. There are roughly 8 billion people on Earth, around 2 billion of those are children. Even if Santa only delivers presents to households with children, and even if we assume just one delivery per household, we are still talking about hundreds of millions of stops. The task for the night is therefore staggering. Now let's be extremely generous. Let's say Santa doesn't have to knock. Let's say he doesn't stop to eat cookies. Let's say he spends just a few seconds per house. Even then, the numbers are brutal. Santa does also get one important advantage though, time zones. By travelling west, Santa can stretch Christmas Eve across the rotation of the Earth. Instead of a single night, he might get as much as 36 hours of darkness. But even with that advantage, Santa would still need to make thousands of deliveries every second. So already this is far beyond anything humans could realistically achieve. So whatever Santa is doing, it isn't normal travel. So let's ask the most obvious question first. What if Santa just goes really fast? To reach hundreds of millions of homes in that time, Santa's sleigh would need to travel at thousands of kilometres per second. That's faster than a bullet, faster than a jet fighter, faster than most spacecraft we've ever built. At those speeds, physics becomes extremely unfriendly. Air molecules don't gently move out of the way, they slam into the sleigh at enormous energy. This creates intense friction and heating, enough to ignite the air itself. So in simple terms, Santa's sleigh would glow like a meteor. Then there are the sonic booms. Every time Santa crosses the sound barrier, he creates a shockwave. Now imagine millions of those across every city, every second. Windows would shatter, structures would be damaged, the night would be anything but silent. And then there's the biology. Acceleration at those speeds would crush anything organic. That includes Santa, his reindeer, even any reinforced materials on his sleigh. So while speed sounds like the simplest answer, it fails spectacularly. Supersonic Santa does not survive the physics. But physics does have something more subtle to offer. Time is not fixed. According to Einstein's theory of relativity, time slows down the faster you move through space. At everyday speeds, this effect is tiny. At extreme speeds, it becomes dramatic. At speeds close to the speed of light, minutes for Santa could equal hours for the rest of us. From Santa's perspective, Christmas Eve could feel long, calm and manageable. From Earth's perspective, he would appear impossibly fast. This effect, known as time dilation, is not science fiction. It is measured and corrected for by everyday materials. GPS satellites experience time differently from us on the ground, for example. Without relativistic corrections, navigation systems would fail. So could relativity solve Santa's problem? In theory, yes. In practice, there are some serious obstacles. Reaching those speeds would require extraordinary amounts of energy. Acceleration would need to be perfectly controlled. Radiation and particle impacts would be deadly. Relativity allows Santa to bend time. However, engineering does not yet allow Santa to survive it. But importantly, physics does not forbid this approach. So the universe doesn't say no, it just says not yet. Santa has another clever advantage. The Earth rotates beneath him. By flying west and following the night, Santa can extend his working window far beyond a single evening. This turns the planet itself into part of the delivery system. The deadline moves, the night lasts longer, time works in Santa's favour. On its own, this doesn't solve the problem, but combining it with the relativistic effects or advanced technology, it becomes a crucial factor. Santa isn't racing against time, he's surfing it. Now it's time to leave everyday physics behind. What if Santa lives in the quantum world? At the smallest scales, reality behaves very differently. Particles can exist in multiple states at once. They don't choose a position until they're observed. This is called superposition. So there's a strange but fascinating idea. What if Santa doesn't exist in one place at a time? What if Santa exists in many places simultaneously? Each delivery is a probability. Each house is a possible outcome. Observation collapses Santa into that location. Is this how reality works for people? No. Is it how reality works for particles? Absolutely. A quantum Santa is wildly speculative, therefore, but it isn't explicitly forbidden by physics. It's absurd, but maybe Santa is just a quantum genius. Now let's discuss a potential elegant solution. Wormholes. Theoretical tunnels through spacetime that connect distant locations instantly. If Santa had access to stable, microscopic wormholes, the problem of distance disappears. He wouldn't fly between houses, he wouldn't cross continents. He would step through space-time itself, one foot in the North Pole, the next in your living room. In this context, chimneys suddenly make sense. They become Santa's fixed entry points, anchors in space-time. The energy requirements would be enormous, the engineering challenges extreme. But according to modern physics, wormholes are theoretically allowed. Santa wouldn't need speed, he'd just need space-time to cooperate. Now let's talk about that list, that naughty and nice list. Tracking the behaviour of billions of children sounds impossible, until you remember that modern systems already track behaviour at global scale. AI models analyse trends. Social media algorithms predict outcomes. Surveillance networks already exist. Santa wouldn't need to watch everyone. He wouldn't judge every action. He could model behaviour statistically. The naughty and nice list becomes a data problem, not magic. And suddenly Santa looks less like a wizard and more like a very advanced statistician. Now let's consider one final possibility. What if Santa succeeds on Christmas Eve, not because of magic, not because of physics-defying technology, but because Santa isn't human at all? What if Santa were an advanced extraterrestrial being? Many of the problems we've discussed immediately become easier to solve. First, longevity. Santa is often described as ageless. Year after year, generation after generation, the same figure appears on Christmas Eve. For humans, that's impossible. But for a long-lived alien species? Advanced biology could allow lifespans measured in centuries. Next, let's look at technology. An alien civilization, even a few thousand years ahead of us, could possess gravity manipulation, advanced propulsion, energy sources far beyond our chemical fuels, materials that withstand extreme acceleration. Suddenly Santa's sleigh isn't magical, it's an alien spacecraft. Reindeer aren't mystical, they're bioengineered, symbolic or ceremonial. Even Santa's workshop makes more sense. A hidden, highly advanced facility in the Arctic would be remote, stable and largely unobserved. Exactly the sort of place an alien visitor might choose to live. Then there's behaviour. Santa doesn't rule, he doesn't interfere with politics, he doesn't change human history. He observes, he rewards, he leaves. That's remarkably similar to how many science fiction stories describe how a non-interventionist alien observer would work. A cultural tradition, a symbolic interaction, a light touch. In this interpretation, Santa isn't here to guide humanity, he's here to observe it, encourage it, and maybe gently nudge it towards cooperation and generosity. An alien Santa doesn't break physics, he simply starts with a much bigger technological head start. So, what's the most realistic scientific explanation? Santa doesn't travel at all. Instead, presents are pre-positioned, delivery is automated, logistics do the heavy lifting. Santa becomes a coordinator, a symbol, the face of a global system. The myth reflects the logistics, the magic reflects the coordination. Less romantic, but it fits everything we know about how complex systems actually work. So, could Santa really visit every child in one night? Not with today's technology, but physics does not completely forbid it. With enough energy, enough time, and enough understanding of space-time, even the impossible starts to look negotiable. Santa isn't a lesson in belief, he's a reminder that wonder begins with a simple question. What would it take? And that question is where science begins. Merry Christmas, and I'll see you in 2026 on the Real Science of Sci-Fi.